Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to solve a differential equation using variation of parameters method. So let's get going. Problem: solve y double dash minus 2y dash plus 2y equal to e power x tan x, or d square minus 2d plus 2 into y equal to e power x tan x using variation of parameters method. So we are given a differential equation of order 2. Y double dash minus 2y dash plus 2y equal to e power x tan x. Consider it as equation 1. We can write y double dash as d square y by dx square minus 2 into write y dash as dy by dx plus 2y equal to e power x tan x. And we can write d square y by dx square as capital D square y minus 2 into write dy by dx as capital dy plus 2y equal to e power x tan x. Now take y common from all the three terms of LHS. We'll get d square minus 2d plus 2 into y equal to e power x tan x. Consider as equation number 2, which is in operator form. Equation 1 in operator form is our equation 2. Say f of d into y equal to some function of x, where f of d is d square minus 2d plus 2 and r of x is e power x tan x. We'll find the general solution to our problem using y equal to yc plus yp, where yc is the complementary function, yp is a particular integral. We'll find yc using the auxiliary equation. Later, using the auxiliary equation, we'll find yp. Okay. Now, coming to the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square minus 2d plus 2, right? Let's replace the differential operator d by m, so that we'll get f of m equal to m square minus 2m plus 2. Then the auxiliary equation becomes m square minus 2m plus 2 equal to 0. Now we need to find roots to this equation, so we are going to apply or use quadratic formula minus b plus or minus square root of b square minus 4ac by 2a. In order to find a, b, c, just compare this equation with the quadratic equation am square plus bm plus c. We'll get a, b, c, where a equal to 1, b equal to minus 2 and c equals to 2, right? Now substitute the values. We'll get minus of minus 2 plus or minus square root of minus 2 whole square minus 4 into a into c by 2 into a, which gives us 2 plus or minus square root of 4 minus 4 to the 8 by 2, which is equals to 2 plus or minus square root of minus 4 by 2. You can write square root of minus 4 as minus 1 into 4 by 2. Now split the square root, we'll get 2 plus or minus square root of minus 1 into square root of 4 by 2. Since square root of minus 1 is I and square root of 4 is 2, then you'll get 2 plus or minus, just replace minus square root of minus 1 with I and square root of 4 is 2. Now take 2 common from the numerator, you'll get 2 times plus or minus I by 2, where 2 gets cancelled and you'll get 1 plus or minus I. Therefore, m equal to 1 plus or minus I. The roots are complex conjugate. So we got a pair of complex conjugate roots. We know that when two roots are complex conjugates, say when a equal to plus or minus ib, m equal to a plus or minus ib, then yc looks like e power ax into c1 cos bx plus c2 sin bx. Just compare these two. Then for a equal to 1 and b equal to 1, we'll have the complementary function. Yc equals to e power 1 into x of c1 cos 1x plus c2 sin 1 into x, which gives us e power x times c1 cos x plus c2 sin x, or C1 e power x cos x plus C2 e power x sin x. Let yp equal to, just replace the constants or parameters with some functions of x, a and b. We'll get a e power x cos x plus b e power x sin x, where a and b are functions of x. Now we can compare yc with c1u plus c2v, or yp with au plus bv to find u and b, where u is e power x cos x and v is e power x sin x. U is e power x cos x, v is e power x sin x, right? Here we are going to find a and b using some formula. We'll find a using integral minus b into r of x by uv1 minus vu1 into dx, and b is given by integral u into r of x by uv1 minus vu1 into dx. If you notice, we are having uv1 minus vu1 in both the formulas, so we'll begin with uv1 minus vu1. Later period we'll find a, b and yp, and finally we'll get general solution by substituting yc and yp in y equal to yc plus yp. Now coming to uv1 minus vu1. v1 is nothing but v dash minus v into u1 is nothing but u dash. This equals to u e power x cos x into v e power x sin x whole dash minus v e power x sin x into u e power x cos x whole dash. Here we are going to apply uv whole dash formula because we are having two functions, right? We need to find derivative of product of two functions. So we are going to apply uv whole dash formula. E power x cos x into e power x dash sin x plus e power x into sin x dash minus e power x sin x into e power x dash cos x plus e power x into cos x dash, which gives us e power x cos x into derivative of e power x with respect to x is e power x sin x plus e power x into derivative of sin x with respect to x is cos x minus e power x sin x into e power x derivative of e power x with respect to x is e power x cos x plus e power x into derivative of cos x with respect to x is minus sin x. This gives us e power x cos x into e power x sin x plus e power x cos x minus e power x sin x into e power x cos x plus into minus minus e power x sin x, which gives us e power x into e power x, since we know that e power x into e power x can be written as e power x plus x, which gives us e power 2x. Right? This gives us e power x into e power x is e power 2x sin x cos x plus e power x into e power x e power 2x cos x into cos x cos square x minus e power x into e power x e power 2x sin x cos x minus into minus plus e power x into e power x e power 2x sin x into sin x sin square x. Okay, here e power 2x sin x cos x minus e power 2x sin x cos x gets cancelled. This gives us e power 2x cos square x plus e power 2x sin square x, or we can just write it as e power 2x sin square x plus e power 2x cos square x. Now just take e power to x common from the two terms. We'll get e power to x times sine square x plus cos square x, since we know that sine square theta plus cos square theta equal to 1. So we'll get e power to x into 1, which gives us e power to x. Therefore, uv1 minus v1 equal to e power to x. Let's now find a, b and yp. Coming to a is given by integral minus v into r of x by uv1 minus v1 into dx. V is e power x sin x into r of x is e power x tan x by uv1 minus v1 is e power 2x dx. This gives us minus integral e power x into e power x is e power 2x sin x tan x by e power 2x into dx. Here e power 2x gets cancelled. Is equals to minus integral sin x into tan x dx. This gives us minus integral sin x into, since tan theta is sin theta by cos theta, so replace sin x with sin x by cos x, replace tan x with sin x by cos x, which gives us sin square x by cos square x, just cos x. Since we know that sin square theta plus cos square theta equal to 1, from this we'll get sin square theta equal to 1 minus cos square theta. So just replace sin square x with 1 minus cos square x. This you'll get minus integral 1 minus cos square x by cos x dx, or minus 1 plus cos square x by cos x. So in the integrand, the numerator of integrand we have two terms, and in the denominator we have one term, so we can split the total integrand into two terms. We'll get minus 1 by cos x plus cos square x by cos x into dx, which gives us, since reciprocal of cos theta is secant theta, so you'll get integral of minus secant x plus, if 1 cos x gets cancelled, you'll get plus cos x into dx. This gives us minus integral secant x dx plus integral cos x dx. Since integral secant theta d theta equal to log mod secant theta plus cos theta, and integral cos theta equal to sin theta. So the above equation becomes a equal to minus log mod secant x plus tan x. It's tan x, okay, not cos x, I'm sorry, plus integral cos x dx is sin x, or equal to minus log of secant x plus tan x plus sin x. Therefore, a equal to minus log of secant x plus tan x plus sin x. Let's find b using integral u into r of x by uv1 minus v1 into dx is equals to u e power x cos x into r of x is e power x tan x by uv1 minus v1 is e power 2x dx. This gives us integral e power x into e power x is e power 2x cos x tan x by e power 2x, where e power 2x gets cancelled. This gives us integral cos x into tan x dx. Since we know that tan theta equal to sin theta by cos theta, so just replace tan x by sin x by cos x. So cos x gets cancelled and you'll get integral sin x dx. Since integral sin x dx is minus cos x, therefore b equal to minus cos x. Now we'll find yp using a e power x cos x plus b e power x sin x. Substitute a and b. That is minus log of secant x plus tan x plus sin x into e power x cos x plus b minus cos x into e power x sin x. This gives us minus e power x cos x log of secant x plus tan x plus e power x sin x cos x plus into minus minus e power x sin x cos x, right? Here plus e power x sin x cos x and minus e power x sin x cos x gets cancelled, and you'll get minus e power x cos x into log of secant x plus tan x. From this we'll get yp equal to minus e power x cos x log of secant x plus tan x. We got yp and have yc. Let's now find general solution using y equal to yc plus yp. Therefore, the general solution is given by y equal to yc plus yp. Then y equal to yc e power cx into c1 e power x of c1 cos x plus c2 sin x. Yp is minus e power x cos x log of secant x plus tan x. Therefore, y equal to e power x of c1 cos x plus c2 sin x minus e power x cos x into log of secant x plus tan x is the required solution to our problem. So this is all for now. I hope you'll understand. We'll see you in the next video. Until then, bye bye.